this one here is an RTX A4000. And this one here is an RTX 4000 SFF ADA version. Now, this is the latest version in a small form factor and features 20 GB of RAM versus 16. Other than that, this has only 70 watts, while this has 140. The really bad part about it, this has a reduced memory bandwidth. Now, looking at the metrics coming out of gaming benchmarks, this one is supposed to be quicker or better than that one. But with all the knowledge we have about memory bandwidth and LLM performance, I have my doubt. So let's find out. Last year, I built myself the, at the time, best home lab AI machine. My goal was to have a machine with a lot of VRAM to use for LLM inference. I could also share among different models at a time for agentic workflows, basically. I think I achieved my goals. Although the critique was fair that this was not a cheap endeavor at all. Well, facts. However, my goals and priorities shifted, or better yet, expanded. I'm now looking at a machine that is more power efficient, so I can run it 24/7 without giving a sweat about the energy bill. Also, the current AI machine is still my go-to machine for many tasks. It's where I test out new stuff, play around with a bunch of things, and along the way break things, of course. In short, this is where I explore and learn. Now, I also want to run things reliably, like Home Assistant, for instance, which is currently running very smoothly on a Raspberry Pi, by the way. The difference is now I also want to be able to use LLMs in a reliable and always available setting. I don't want to start and stop things. I want to expose my own private chat client, public N8N instance, and a simple image generator for everyday tasks. Like nothing spectacular. I actually wanted to make another video about it, but in short, I ordered the Minis Forum MSA2 back in June, but due to high demand, I won't be able to get my hands on it till, I think, end of August, according to the support. Anyways, I was planning on buying something like the MSA2 or the MSO1 for a while, and that's why I bought this one in the past. Or is it this one here? A NVIDIA RTX A2000. Unfortunately, over the last year, I noticed that with 6 GB of VRAM, well, LLMs do not perform particularly well with so little RAM, especially when you account for a decent context window size. The LLM versions get really tiny and are not exactly powerful. And this is what brings me to today's topic of the video. I was looking for a replacement of my A2000 with something more memory that could also fit into the MSA2. That's why I sniped a deal on eBay for this one. You saw in the intro. It's an RTX 4000 SFF ADA version, graphics card with a newer chip generation and 20 GB of VRAM. Just shy the 4 GB of the best consumer graphics card at that generation, the 4090, which being power efficient and really tiny at the same time. I mean, 70 watts. Not tiny enough to fit into an MSA2, but I already got the kit from Nerdware that will solve that problem for me. They created custom cooling solution with a beautiful copper block to actually fit the low profile single slot PCIe interface. If I ever get that machine, I will let you know how that went. I already own the RTX A4000, non-SFF, but the Ampere version of that card. As I showed you earlier, here, this one. Just from these specs and the context, could you guess which one is better? I mean, they both have the same memory size, CUDA, ray tracing, and tensor core count. Well, I really couldn't tell, with confidence at least, which one is faster, and got me curious if the SFF model of the new generation in a really firmly constrained environment like this tiny card with exactly half the power of the previous generation, and I'm not sure if you noticed, a significantly slower memory bandwidth, could compete. Now, I don't know if you watched any of my previous videos about performance. If you don't, you definitely should. shameless plug, I actually talked about the importance of the memory bandwidth and how this will most likely be the key constraint of the upcoming NVIDIA Spark. Thanks to my awesome viewers, I also learned that I neglected the context size of the prompts in my testing, so I corrected that here. I now run my test with a very small 550 and a larger 20,000 token context window. The small one is great to see the performance of pure inference of the model and is primarily influenced by the memory bandwidth of the card. This is a great test if you just want to chat with a model. The larger one is more representative of a very large chat history, a code base, or a RAG system you're interacting with. Here, the compute performance is coming more into play and more processing power. You know, those infamous flops are now having to show for their worth. Okay, now do me a tiny favor and pause the video for a sec and rank the two video cards. Which one will be the best in what scenario? Or is there a different winner depending on the scenario? Like small versus large context size? Seriously, I mean, we humans have, and this is backed by science, the tendency to find logical explanations for everything once we know the answer. I mean, just read Watt's book about everything is obvious once you know the answer, or basically how common sense fails. I do that exercise on a regular basis just to remind myself that, in fact, I am wrong with a lot of things. Post it in the comments and see what others thought, if you like. This exercise at least helps me to stay grounded. It might help you too. Okay, back to the topic. You picked your winner, and here's the great reveal. Looking at mere throughput, we see that for a small context size, the older A4000 is beating the newer version by over 130 tokens per second for all requests combined, mind you. With the large context window, we have basically the same results within the margin of error. Here we see the benefit of the improved flops of the newer card. With even greater context size, this will only increase, but with just 20 GB, this is a scarce resource. Now, looking at the tokens per second per request, we are faced with a very different picture. Here we see around 30 tokens versus 20 tokens for the small context size, and again 30 versus 15 tokens for the larger context size in favor of the older card. In the previous chart, we saw the SFF card catching up with the larger context size. But here we see that this is achieved with a degraded performance on the per request speed. For enterprises, this might be great to see that you could handle more actual compute when this doesn't affect the response time of your users. However, if the response time is important to you, the SFF card is clearly not ideal here. Talking about response time, the time to first token is also particularly clear. In both scenarios, the older Ampere card is superior. Interesting though, the performance took a noticeable drop with the larger context window. I mean, there's processing involved, obviously, so this is kind of expected, but I found the amount rather significant. Pretty much exact 1.5 seconds difference in the worst case. That's a lot. This also illustrates nicely the problem with larger context windows. They are nice and convenient and are a great way to find the proverbial needle in the haystack, but they do come at a cost, response time. Your 2 million token context window is not only monetarily expensive, but also compute. RAG systems with databases have similar issues of being slow. I'm curious if you've seen mixture of experts for context windows to save on compute by intelligently routing requests, especially when the context is split across GPUs, similar to the LLMs. Well, maybe this is already done, but I didn't notice. Let me know if I missed that one. Anyway, as you can see, the newer RTX 4000 SFF ADA version was beaten in pretty much all tests. The new chip generation was not enough to make up for the significantly reduced power, reduced memory bandwidth, and clock speed. For our current test, it's clear that the new chip architecture does improve performance, but the amount is just not enough to compensate for the cuts made in other areas. Also, If you made the foolish attempt to guess the performance solely based on mainstream performance metrics or tests, mostly from gaming-focused sites, you might have gotten a wrong impression. Just look at this site, and this was just the first one I found on the web. It surely looks like the latest generation is better compared to the old one, obviously. Even the spec sheets from NVIDIA is making a strong point, but funny enough, not comparing to the older A4000, but the A2000. Okay, this brought me into an entire rabbit hole of what should be a valid contender to compete against. I'll save you the details and jump right into it, what I think is the combination. First of all, it's important to understand that for many use cases only the RTX 2000 ADA and the RTX 4000 SFF ADA, which basically have the same form factor, are opinions for my build. However, I wanted to understand where are we standing from an LLM performance perspective. In other words, what are we giving up for choosing the small form factor versions? And as a reflection, is it necessary? When looking at the specs side by side, there are a few things that jump to mind. The first for me was that this table is incredibly symmetrical. I highlighted the difference in each row to better see them. On the left, we have the old card with Emperor generation, and after that, we have the increasingly more powerful cards to the right. The A2000 has less than half the compute performance according to the core count. The only metric where the 2000 card is slightly worse is the memory interface and bandwidth. In the testing with a cloud-hosted version, however, I noticed that my standard test setup with 64 parallel threads and 64 requests was returning strange results. One day everything worked fine, and a week later, when I tried to rerun some of my tests and establish a baseline with my previous setup, well, everything fell apart. Many of the requests just failed. First, I thought my setup, network, or something along those lines was wrong, but then I noticed that the system simply couldn't handle the load anymore. Instead of 64 threads parallel processing, I had to drop down to 10. I know, this is not a metric many of you are interested in. I mean, who's bombarding his home lab with parallel requests until it breaks? Except me, maybe. Well, not many yet, I guess. But with agents and agents talking to agents, this might very well become an issue in the not so distant future. Weirdly enough, the rest of the metrics stayed the same. The same throughput, the same tokens per second. I'm still a bit puzzled to why, but I guess this is yet again one of those mysteries. Anyway, looking at the test results, the picture is pretty weird. From a throughput perspective, the old A4000 beats the competition. My guess is entirely due to memory speed. Second, from a throughput speed, the SFF version is faster than the regular ADA version. This just can't be. Something is wrong. Let's look at the time to first token. Here we see an obvious issue. We are talking now about almost a minute instead of milliseconds for the cloud-hosted versions when it comes to the large context window tests. I thought my 50 Mbit upload was enough, although on the closer end of what's ideal, I estimated that I need about like 41 megabit per second. However, there seems to be an issue, either on the latency side or on the mere upload speed. I tested my upload speed from my machine and everything should have been fine based on these. The results for the token per second for each request paint a similar picture. Large context size tests in the cloud fall short regarding their performance. Other than the puzzling aspect of it, I find this very interesting from a usability perspective. I advocate for local LLM solutions where possible as well as reasonable. And this is a good case. When you're dealing with large context windows, having to force data through a potentially unreliable network that is out of your control will have its toll, sooner or later at least. Other than that, we saw that the performance of your regular RTX 4000 ADA being inferior to the older A4000 Emperor version. Sure, this is only for a very tiny use case of LLM inference, but still, this was, at least for me, pretty unexpected. I'm not a hardware engineer, But for me, this pretty much looks like a calculated move to place the cards in their respective marketing place. I understand that this is in fact a valid point, and okay, from a business to do in order to avoid cannibalizing other products. But on the other side, it also kind of stinks. I'd love to have the 4000 SFF ADA with the same memory bandwidth as the regular 4000 ADA version, non-SFF, just with less power. For my use case, the power limit will never be an issue because I only do short bursts where memory bandwidth is more important than compute. I would even argue that for me, a Frankenstein card with the amount of core compute of the A2000, but the memory bandwidth and capacity of the 4000 ADA or even greater would be perfect. I don't have large context sizes. I don't train, most of the time at least, and I use it in bursts instead of constant loads. Unfortunately, this piece of tech wouldn't fit into the well thought out product catalog of NVIDIA. It would be a new category with lightweight LLM inference optimized cards. In our current day and age, this might actually be a new direction to get PCs equipped with comparable hardware for local LLMs that is fast and could run decent models. These cards won't be able to do heavy training or hardcore gaming, but especially for engineers or in general business people that need such local power for LLMs in the masses, this might be a new market. Well, till now at least, they didn't need a fancy graphics card for their work tasks, but in the future they might, or they won't. When done right, it could serve this very specific niche without cannibalizing the other areas. Well, we'll see. One can dream. Anyway, I was actually trying to convey a different point. We should never look at some spec in a vacuum. Specs in real life usually affect each other, and your use case is key regarding what combination of specs is relevant for you, as seen with the reviews of the RTX 4000 SFF ADA version. The reviews were great and the specs are not bad either. But at the end, a seemingly worse contender, the older A4000 card, wiped the floor with the others. Well, not that dramatic, but being better than your successor, that's something. As a disclaimer, despite all my efforts, the test might be flawed. So decide for yourself what is important to you and check multiple sources, or even better, do your own tests. With cheap, on-demand resources available, everyone could just run a test bench in a couple minutes. Guessing and comparing performance of new systems without anything to go with, that's just doomed to fail. So I yet again end another plea from me to create a more standardized test setup for GPUs in the realm of LLMs. My focus is very much inference based, but others will certainly be interested in training, others in image or even video generation, which I haven't even touched here. Requirements on the cards will be very different, and I'd like to see a test suite that makes GPUs more objectively comparable. For me and my little side project here, I guess I'm fine with the RTX 4000 SFF ADA card. It's not as good as I hoped it would be, but the best card that could fit my build, once I get the MSA2 at least. The 2000 ADA version is honestly not as bad as I thought, especially if you get a good deal used. Fun fact, the DGX Spark is right between the two cards regarding the memory bandwidth. I'm really curious to see if this indicates its performance range. Check out my last video about the Spark and my concerns about it here. Well, that's all. Just a quick one this time. I am working on more, so leave a like to encourage me to continue and consider subscribing if you want to see what I'm up to. Till then, servus.